Hello everyone. This video is part of a playlist that aims to explore networking protocols with the help of a device that's easily accessible, and that's the ESP32. In this video, we will take a look at the network time protocol through a simple sketch. The video will be split up into three main sections. First, we will explain some terminology. Then we will give a brief introduction on what the network time protocol is, and then we will implement what we've learned so far through a simple sketch. The tools we will need are the ESP32 board and the Arduino IDE. The network time protocol is a networking protocol for clock synchronization between computer systems, and it is one of the oldest internet protocols that is still currently being used. Before we start, let's clarify some terminology. First, the client-server model for communication. In this communication or network model or pattern, there are two kinds of processes. We have the clients and the servers. The client starts the communication by connecting to a server. It does that through sending requests to the server, and the server sends replies back. After obtaining the responses, the client can disconnect. A server might handle connections from many clients concurrently, and clients can also connect to multiple servers. Now that we've introduced the client-server model, let's take a look at the network time protocol and how it works. The network time protocol, or NTP for short, is made up of the stratum architecture, where in essence, that means it is a hierarchical structure, where each level represents a step in the NTP server architecture. When we take a look at the NTP stratum architecture, we can see that in the first level, or the stratum 1 level, we have servers connecting to a reference source that is essentially the accurate clock source. And examples of that would be the atomic clock or a GPS signal source. Then the time signal is cascaded to a stratum 2 server, where it acts as a clock signal repeater. And this is to relieve the primary server from the effort or demand of responding to queries or requests. Similarly, the time signal will travel to the stratum 3 server from the stratum 2 servers, and so on and so forth. The NTP Pool project is a project that was launched in order to access timekeeping with high precision. It basically connects the very large clusters of virtual servers of NTPs to the internet. Pools of servers are located in almost every country on the planet, and this enables clients to use a nearby server, reducing round-trip delays and improving the integrity of the response received. In this video, we will use the NTP Pool project to display time with the help of our ESP32 board and display it onto our serial monitor. NTP can operate in a number of ways. However, the most common configuration is to operate in client-server mode. The fundamental operating principle is as follows. The client device, which in our case is the ESP32, will connect to the ENTP server. And the one that we will be using is the pool.ntp.org, or more specifically, the asia.pool.ntp.org. Then the client will send a request packet to the NTP server requesting time. In response to this request, the NTP server sends a timestamp packet, which will contain a variety of data such as accuracy, delay, or time zone, and the client can extract the needed information from it, which is the date and time, and after that the client can disconnect. The NTP Pool DNS system automatically picks time servers which are geographically close to you, but if you want to choose explicitly, there are subzones of pool.ntp.org. for the continent you are in. As you can see in the table, there is one for every continent. If you'd like to access a specific country's server, you can do so through navigating over to the NTP pool project and looking for your country. Before we move on to the code and the simple sketch that we'll be working on, it's important to realize that there are two offsets that we would need to identify and specify for us to get an accurate time reading. I will be linking a list of UTC time offsets for different countries in the description below. And you can calculate your time zone through looking at the UTC offset and multiplying that number by 60 and another 60. So an example is, if your country is in the UTC offset of +3, then you would need to multiply 3 by 60 by 60. Whereas if your country lies in the -5 UTC offset, then you would need to multiply -5 by 60 and by 60. Another offset that we would need to consider is the daylight offset. If your country observes daylight saving time, you would need to set it to 3600, and if it doesn't, you would need to set it to 0. So let's implement what we've learned so far through a simple sketch that you can find in your Arduino IDE. Navigate over to File, then Examples, go over to the ESP32, and then click on Time, Simple Time. This is the sketch that we will be modifying to implement this simple project. First and foremost, we would need to include the libraries that we will be using in the sketch. Then you will specify the NTP server that you will be using. In my case, I will be using the one in Asia. We will only use the NTP server, the first NTP server. We don't need the second NTP server, so we can go ahead and comment this out because we will use the pool project to access the time packets information. I've defined the NTP server that I'd like to connect to, which is the asia.pool.ntp.org, since the country that I'm trying to find the time and date information for is Dubai, and Dubai obviously lies in Asia. Then we would need to calculate the GMT offset, and for that we would need the help of the Wikipedia, of a Wikipedia page that contains the list of UTC offsets. So you can just search up your country or your city. So I will search up the city of Dubai, and we can see that it is in the +4 UTC offset. And therefore in the code, we have multiplied 4 by 60 and then multiplied that by 60 as well. This country, this city does not have a daylight offset, so we've set it to 0. Now let's take a look at the code. We don't need this time zone. We can see that there is a function that has been created which prints out the local time. First, it creates a structure, a time structure for the time packet that we will receive. It will use a method or function to get the local time and store it into this structure. And as long as this is empty, it will print out the message that we have still not received any time information. However, when we do receive time information, we will print out specific values or properties of that time packet. And these are represented by different symbols as shown over here. The code will print out the day of the week, the month, the day of the month, the year, the hour, the minutes, and the seconds. As you can see, this table essentially lets you know which which character to use to return a certain aspect or detail from the time packet received from the NTP server. For now, I will comment out this section of code, and then let's take a look at the setup loop. Of course, we set up the baud rate, and we also configure the Wi-Fi connection over here. This is what it does. We make sure that we connect to our access point, since we will be using the help of our access point to connect to the NTP server that we've specified. Then we would need to configure this connection with the GMT offset that we've just found for the city of Dubai, the daylight offset, and the first NTP server, as that's the server that we will be using to connect to the NTP or the pool project. Then through the loop, we will just go ahead and call the print local time function, and if everything is set up correctly, we should observe the time for the specified country. You can now go ahead and make sure that you're connected to the appropriate COM port. Make sure that you've chosen the appropriate ESP32 board and flash your ESP32 with this code. After flashing the ESP32, open up your serial monitor. And with that, we have demonstrated what we have learned so far using the knowledge we've acquired on what the network time protocol is. Thank you for watching this video. If you found this video useful, consider subscribing or supporting the channel through Patreon, where the link for it is in the description below. You will also find the code for this tutorial series in the description below. And as always, thank you for watching.